Okay, I'm just going to briefly explain project 1 here. So as you can see, we have a function right off the bat to traverse a linked list and return a node with the given value. Here we have the PCB class implemented as required by the documentation. Here we have the control block class where, well, the PCBS class, or the list. This is basically a list wrapper so that we can get some basic functionality on a list. This first function gets the first available index, whether it's none or it's going to be the length of the list. Then we do on create. If the first, or if process 0 doesn't exist, we're going to initialize it. We're going to get the first available index. Then we are going to allocate a free PCB. Again, we're going to either insert or we're going to append it at the very end. And then we're going to set the parent of item Q. And then we're going to set the child of item Q to a new linked list. Then we append the item Q as a child of item P. On destroy here, this is a recursive function, so these first two lines we're just setting some variables to make the syntax below a little more clear, so we're not constantly indexing into things, making it hard to read. And we just iterate over the children in the list. We're calling destroy on every item, and then we are setting item Q equal to none. Then we are traversing the linked list, grabbing the node with the correct value, and we are removing that node from the linked list. And then finally, we deallocate item P. Okay, so now on to PCBB. So this is the second implementation here with the required fields. So this is the non-linked list version. This is just a list. So get item Q, that's the same, that's going to give you the first available index. Now create, this is again just initialization. If process 0 doesn't exist, we're going to initialize it. And then we're getting the first available index. We're inserting or appending at the given index. Parent and child, we're just setting those aliases, so this is more clear to read. If the parent doesn't have a child, we're going to set that child and we're going to give the child a parent as well. And then basically here we're just going to iterate through the siblings. We're going to traverse down the siblings until we get to where there is no siblings, and then we're going to append at that point. We're going to set the sibling here, and then we're going to give the child an older sibling at the given index. Okay, and then this destroy, this is again a recursive function. We're just setting PCB here. We're grabbing the right one out of the list, and then we're going to traverse. Well, we're going to destroy the younger sibling if it exists, and we're going to destroy the first child if it exists. So we're taking care of parent relationships, and we're taking care of sibling relationships. And then finally we set PCBS item P to none, so we deallocate that. Okay, so that's pretty much it. Now I will go to my testing functions here. So this, I just used the example from the video. So we're going to create and then destroy in the order that was specified in the video. And we're going to do this many iterations. I believe this is what, 1,000,000 iterations. And we're going to just go and we're going to do the same thing for the process control block linked list and the process control blocks list. And we're just doing any number of tests for both of those. So let's go ahead and run this. And it's just going to give us the time difference there. Okay, and you can see it cut our time down in half. So it's a pretty good improvement. Interesting project. Thanks for watching.